Chapter 1, Section 3, Problem-Solving Strategies. George Polya was a Hungarian mathematician known for problem-solving strategies. He was a professor of mathematics at both ETH Zurich University and Stanford University. In addition to this, he wrote 5 books on heuristics and problem-solving. Now, the reason Polya is so well known is because he came up with a 4-step problem-solving procedure that many mathematicians use today. Step 1 is to understand the problem. Now that seems simple enough, but I'm sure many of you have experienced looking at a word problem, being completely lost, and just moving on. I know I have. And it's something that we need to try to get over this fear and anxiety around word problems. And instead, let's break it down piece by piece, read each sentence, and just try to understand what the problem is asking us to do. You know, that might be within all of the wordage and verbiage of your word problem. Maybe at the very end it just says, how fast is the car traveling? Well, at least we understand right there that the point of this problem is to find the speed of the car. Right? So if we can break it down just to the basic understanding of what are we supposed to be looking for, hopefully that will help get us started on how we might be able to solve the problem. So read the problem slowly, jot down the key ideas, figure out what it is you want to find. Step 2 is to devise a plan. Now this is the part where we all seem to stop. We don't know how to solve something immediately, and for some reason we tell ourselves, well, then I can't do it. And that is not true. We need to go through some trial and error very often in mathematics. So what we do is we come up with a plan that may or may not work, and we just have to be brave enough to try it. You know, and when you're doing your homework by yourself, it really doesn't matter if you're wrong, no one's looking, right? Or if you come to office hours and we work on a problem when we start it wrong, who cares? Because we're going to learn how to do it right the next time. So come up with a plan and try it. Do some trial and error. Draw a picture. Think of a formula you know that uses one of the key words from your problem. Are there any patterns in your problem like we discussed with inductive reasoning? Pull from your mathematical tool belt and think, what could I maybe do to try to figure this problem out? Step 3, carry out the plan. So if your plan was to draw a picture and then see if you can figure out things to multiply or add, or how tall something is, or how shallow, try that, see if it works. If your plan was to use a formula that you know about, try to use the formula, see if it works. You know, but once you carry out the plan, you might get an answer. That doesn't necessarily mean that your answer is correct. So step 4 is to look back. Figure out, does this answer actually make sense? Oftentimes, students will do a math problem, get an answer, and move on. I know this because I have graded exams that ask for things like the speed of a car, and I get answers like negative 412 miles per hour. That should be a red flag. We should know that cars don't go negative miles per hour, right? And definitely not negative 412. And if you get positive 412, something probably went wrong there too. So look at your answer, see if it makes sense. Just because you got a numerical answer doesn't mean that it's the correct answer. So we want to look back, we want to think, does this answer fit what I was looking for? Did I solve for the right thing? Was I looking for the speed of the car? Or was I looking for the distance traveled? Make sure you answered the right question. And guess what? If it wasn't right, just go back to problem 2 and come up with a new plan. Nobody's watching you work. There's no reason to be embarrassed. There's no reason to feel any sort of shame. All we're trying to do is think logically, think critically, and try to train our mathematical brains. The more you try, the better you're going to get at it. So though his problem-solving procedure is not like some magic equation, some magic process that no one ever told you about. It's actually a very simple process and probably a frustrating process. It is a good practice to go through when dealing with word problems and dealing with everyday life situations too, right? Sometimes something comes up in your life. You first need to understand what's happening. You need to come up with a plan for how you're going to fix it. You carry out the plan and you hope it worked. And if it didn't work, you start over. Right? We all have to do these types of things in our everyday life, so it's a good way to train your brain by doing it in math class. Let's try this with exercise 1. A gardener is asked to plant 8 rose bushes that are 36 inches tall in a straight line with 2 feet between each plant. How much space is needed between the first plant and the last one? And then second, can you devise a formula to find the length needed for any number of plants? Okay, so the first thing we're supposed to do is understand this problem. So I'm just going to read through it again, kind of slow. So this gardener was asked to plant 8 rose bushes that are 36 inches tall in a straight line with 2 feet between each plant. How much space is needed between the first plant and the last plant? So I basically just went through and highlighted all of the math words, but what I'm realizing is I'm only asked about basically like horizontal distance. I'm never asked about how tall the plant is, so I don't think that information was necessary. So I erased that. Everything else I have highlighted I think is good. So understanding this problem, I know that I have 8 plants in a line. And I also know that I have 2 feet between each plant. And what I'm looking for is how much space is needed between the first and last plant. So really the important part of this is how much space between first and last plant. So sometimes when I'm doing these problems, I write down what I want to find, and I write WTF, which I know is not typically used to stand for want to find, but that's what I write. So if you see me write that, please don't think I'm cursing. I'm just saying what I want to find. When I was in college, I used to write it on my homework, and one of my TAs finally asked me why I wrote profanity on all my homework, and I didn't know what he was talking about. And then when he showed it to me, I was like, oh my goodness, I'm so sorry. It means want to find. And we both laughed, and I never stopped writing it. So that's okay. So what do I want to find? I want to find the total distance from the first to last plant. Okay, I think I understand the problem, at least part A. Move on to step 2, devise a plan. So right now I would like you to pause the video and come up with something that you think will work to figure out this problem. Remember, when you devise a plan, you can draw a diagram, you can try to use a formula, you can look for a pattern, anything like that. So give yourself a few minutes to sit there and come up with something. And then once you've come up with a plan, jump down to step 3 and try to carry out your plan. Please actually pause the video and let yourself try. Then come back and we'll talk about it together. Okay, so I don't know what plan you came up with. I'm sure whatever it was great, it was a great attempt, or maybe it worked. I'm happy with either, just to know that you tried. What I would like to do in this problem, or what I originally thought to do, was since I'm talking about plants in a straight line, I'm just going to draw them. So my plan is to draw a picture. Maybe some of you guys just guessed. Like when you first read the problem, you thought, well, I got 8 plants and I got 2 feet between them, right? I got these spaces. So maybe it's going to be 8 times 2. Maybe it's 16 feet. That's a common guess I get with this type of problem. So let's see if that picture would match that guess. Okay, so now I'm going to do step 3 and I'm going to carry out my plan by drawing my picture. Okay, so I have 8 rose looking plants. They look good enough. I have 8 of them, and my idea was to draw a picture and just count, basically. So here I have my first 2-foot gap, my second 2-foot gap, my third, my fourth, my fifth, my sixth, and my seventh. So in total I have 7 of these 2-foot gaps. So if I add all of those together, I see now that I actually think I was supposed to have 14 feet from the first plant to the last plant. Well, it's different than the original guess I had, right? I just said 8 times 2, which I thought was 16. But now let's look back and see, does this make sense? Well, I have 8 plants. So I originally thought I needed to do 8 times 2, but 8 plants implies that I have only 7 spaces. So I only have these 7 spaces, or these 7 gaps actually between my plants. I don't care about this space here because there's no plant here, right? So I actually guessed a number that was too big. So does this make sense? I would say yes, because 7 spaces times 2 feet for each space does give 14 feet. Okay, so that's just an example of how you could run through this problem-solving strategy. So rather than just looking at a problem and saying, oh, too many words, I don't know where to start, I'm going to skip it, which you shouldn't do because on tests, word problems are usually worth a lot of points. Sit there, write down the things that you do understand, write down what you're trying to find. Just try something, anything, try anything to see if you can get anything to come out of it. Work through it and see if it makes sense. And you know what? By going through that process of working through it, especially if you get it wrong, it might inspire you to have another idea that you can try the second time you go through. But unless you put that initial effort in and try that first thing you came up with, you probably would never think of the second thing to try or the third thing to try. So just do your best to try not to get overwhelmed with word problems or to fall into that mindset of word problems are hard. You just need to come up with that initial step to get started. And the more you practice, the easier it will be to do any word problem. Now, there was a part B to this problem, which asked if we could come up with a formula for any number of plants. So in our drawing, basically we had exactly 8 plants, right? So it was a very specific problem. But we noticed that when we had 8 plants, we had 7 gaps. So if I had to guess, if I had 10 plants, I probably have 9 gaps. And if I have 20 plants, I probably have 19 gaps. Or I always have one less gap than I do plants. So I'm going to use an arbitrary number. I'm going to call it n. Do you guys remember that from the last video? We had our deductive reasoning. We had an arbitrary number x. Well, here I'm just going to use n, where n can be any number of plants. I should always have one less gap than I have plants, though. So there would be n minus 1 gaps. And these gaps that we're dealing with are 2 feet. So how could I find the total length if I know that I need 2 feet for every gap and I have n minus 1 of them? Well, I can do the same thing I did up here and I can just multiply those values together. So there would be 2 times n minus 1 feet. Again, if I plugged in 8 for n, I would have 8 plants. 8 minus 1, which is 7 gaps. 2 times 8 minus 1, or 2 times 7, which is 14 feet. So it did work for our problem, and it should work for any number of plants, n. Okay, now that we've worked through this problem together, why don't you take a second and try problem 3 on your own. You can use the 4-step strategy that we just talked about and see if you can come up with a way to solve problem 3. Problem 3 says Megan's car gets 28 miles per gallon on long trips. She leaves home, bound for a friend's house 370 miles away. If she makes the drive in 6 hours, how many gallons of gas per hour is the car burning? Okay, let's start by understanding the problem. So I see some math here, or numbers. Her car gets 28 miles per gallon. The trip's distance is 370 miles. And it's going to last 6 hours. And what do I want to find? I want to find the gallons per hour that are being burned. So I really am going to have to pay attention to my units here. Notice that the car gets 28 miles per gallon. The house is 370 miles. The drive is in hours, but I want to end up in gallons per hour. So I have all these different units happening here. Okay, so I think I understand the problem. Now I need to come up with a plan. And honestly, I think we just need to divide a lot and pay attention to units. Okay, so step 3, I'm going to try that. So I'm going to start with the distance that she's traveling. That's in miles. I can divide that by the 28 miles per gallon. And that should tell me how many gallons of gas she used for this trip. Okay, so when you divide 370 by 28, you get roughly 13.214. Okay, and the miles go away, so I'm just left with gallons. And if you want to see this as like a bigger fraction, which is something we'll talk about later in this course, we could write this as fractions. So we get 370 miles. I'm just going to write it over 1 so it looks like a fraction. And over here, we have 1 gallon for every 28 miles. Right? 28 miles per gallon means that we get 1 gallon will take us 28 miles. So notice that we have this common unit of miles in the numerator and the denominator, which will cancel out. And then if I multiply straight across, I have 370 times 1. On the bottom, I have 1 times 28. And the only unit I have left is gallons. So that's how I knew that I was going to end up in gallons and those miles were going to go away. Okay, but now I'm dealing with how many gallons I'm going to use during this trip, but I don't know my gallons per hour. But I do know how long she's driving, so I'm still going to keep dividing. So if in total she used 13.214 gallons and she drove for 6 hours, doesn't this leave us with the units we want of gallons per hour? And I'm going to round this. So let's practice our rounding again. Let's round to the nearest tenth. So that means I'm looking here at the tenths place. Next to it I have a 0, so I round down. So it's approximately 2.2 gallons per hour. Okay, and then step 4, does this make sense? We didn't get back something ridiculous. So I think the answer we got is sensible. You could kind of work your math backwards. You could do like 2.2 times the number of hours, which is about 13.2. So I'm assuming I used about 13.2 gallons, and the car gets 28 miles per gallon, and I used 13.2 gallons. So if I multiply that by 28, because that's how many miles I should get for every gallon, I get 369.6, which is very close to the 370 miles she had to travel. So I think this was sensible. Once you're confident with your answer, you should box it. Okay, so hopefully these steps will encourage you to spend a little time on your word problems and not get overwhelmed. And just guess and check sometimes, do some trial and error. It's better to try something and end up being wrong than to leave it blank. Okay, and that is the end of chapter 1.